Hi, Amy. How are you doing?
Hi, sir. I'm all right. How are you?
Very good, very good. So now your examinations are close by. How is your preparation going on?
Yeah, it's all right. I'm starting from like the beginning because of the way we put it down. It's like the pure is more weighted in terms of percentage and marks. So I'm like focusing more on the pure, and then I've got the statistics and mechanics going on as well, side by side.
I
Yeah, definitely need to review everything over and over
you,
again. So, yeah.
yeah, in the last minute you have to review everything. It's kind of
Right.
a very tricky process. So
Yeah.
I thought we could discuss a way so that students really get benefit of, adopting a method which could help them review before the final exams.
hmm Most
So
efficient way,
yeah,
hopefully.
so let's see your curriculum. Can you share with me what are all the topics which you have in mind, the contents of your book, which
Yeah.
you need to review, and then we can work out a method or very efficient way of doing the same thing.
All right. So in terms of topics, there's about let's say 10 or 15, 10 or 11 topics so far that we've like done, and obviously within each topic some are a bit more weighted in terms of content and the others are a bit more easier. So yeah, we got like algebraic expressions, quadratics, equations and inequalities, graphs and transformations, circles, straight line graphs, algebraic methods, binomial expansion, and like Pascal's triangle and that,
Mhm.
trig ratios, cosine sine, trigonometric identities, and differentiation and integration, so both of the calculus parts, and then vectors, which
Vector.
we
There
just
are
started.
about 14 points which you told me, which are there
Oh,
uh,
right. Okay.
in this particular thing. Now, which are your strong points and which you think are not so strong out of these chapters?
Um, well, the thing is, like, when we were discussing, so I had a paper that I got from school, and I had to go through it. And obviously, from the paper, it's just pinpointing different parts of all these topics I mentioned. So when I do these questions within the book, there's examples within it. I obviously can do it because I know that it's within that section, so I'm going to get the hang of it. I'm in that mindset. But when I'm out of that mindset and then I'm doing a past paper, which is like containing everything,
Yes.
that's when it truly shows whether I understand it or not. So I think I'm definitely weak at certain points. You know, these small things that you're supposed to remember, like formulas and little tweaks and things like that. Yeah, definitely, it's a bit
Right.
iffy for me. Yeah. So I guess when I do the past paper, I can find out where I've not so
Sure. So
strong.
that's always actually brilliant that when you want to prepare for an exam, you should look into the past papers, right?
Yeah. Yeah.
Just as you're doing. So, as you're saying, can you share some past paper? We'll go through that past paper and then we will work out a plan for you.
Sure.
You can share the screen with your past paper and then we'll go through it.
Right. Uh, so this is pure.
Okay.
Uh, yeah. So we start with question one and kind of work
Let's
through it.
start with question one. Yes. So, can
Okay.
you please read the question and answer?
Yeah. Okay, so the line L1 has equation 2x plus 4y minus 3 equals 0. The line L2 has equation y equals mx plus 7, where m is a constant. Given that L1 and L2 are perpendicular, part A, find the value of m, and lines L1 and L2 meet at point P.
Mhm.
B, find the x-coordinate of P.
How will you do this question?
All right, so I think the key word in that question would be perpendicular. So since we have L1's like
This
equation,
yeah.
if I were to do it, I would have just put that into the y equals mx plus c form.
Right.
And then since I know that they're perpendicular, once I find the gradient of L1, it would just be the reciprocal. So you would have to find them, like the gradient of that would be times a value of that would give -1 for it to be
Right.
perpendicular. So then that would be the value of m. In this case, it will be 2.
Will be 2. So that is how you're going to find the slope. That is correct. So you know all the concepts of line, they are so simple. But let me tell you one key thing, which is where you can find this perpendicular slope directly from the given line. When you have an equation of line in standard form, we said this is standard form, correct?
Yeah.
Now, standard form gives you normal. Normal means perpendicular form.
Yeah.
It gives you normal. So when you have an equation which is of the form ax plus by plus c equals to 0, in that case, the normal, uh, the slope of normal which they want, which is perpendicular, is the ratio of these two, the coefficient of x and coefficient of y. So it
All
is
right.
straight from here, you could write 4 over 2. So that becomes the normal. When you learn vectors, which is a part of your course, which is of course the last chapter in your unit,
Yeah.
but since the whole thing you have already studied, so we write that normal is basically equal to, in this case, a comma b, right? Do you understand? A comma b,
Mhm.
where a is change in x and b is change in y, to find the normal. Do you see that? So when
Yeah.
we're talking about the slope basically is change in y over change in x, correct? And therefore, in this particular case, you get 4 over 2, which is 2. So you get the same answer. So in case, you do shortcut or save some time somewhere,
Yeah.
you could use the knowledge which you have gained in vectors right here also. But of course, the method you did is perfectly fine to get full marks too, which I mentioned here, correct?
All right. Okay.
How do you find the point x where the coordinate of x where the lines intersect? How will you do this part?
So you just make the two equations equal to each other
Yeah, and then
and then
equate.
solve.
Perfect. So this chapter is good for you. Continue.
Um,
Yes.
okay. Find using algebra all real solutions to the equation.
Okay.
So 16a squared equals 2 root a, and part b to the power of 4 plus 7b squared minus 18 equals 0.
Correct. So how will you do part A? Part 1, 2, 1.
Okay. When I was actually doing it, I was thinking of squaring
Okay.
both sides, but I realized,
Yeah.
don't I lose a solution when I do that?
Well, if you square both sides, you get 16 square a to the power of 4 equals to 2 square, which is 4. Let me write 2 square. And square root a becomes a, right? So you'll
Yeah.
get this. After that, what will you do?
Can I take like the common variable? So I'll put 16 squared over 2 squared,
Yeah.
or the other way. I
Right.
don't know.
So one mistake you could do, and that is mistake will be to cancel the A's. You get the point? If you cancel the A's, you will actually lose a solution. So in
Right.
this
Yeah.
case, it is very important to bring them all together. You get the idea, right? So
Mhm.
you have to bring them all together. You get 16 square a to the power of 4 minus 2 square, I can write as 4a equals to 0. And now you see 4a is common, correct?
Oh,
So
right.
you
Yeah.
factor for a, which will give you one of the results as a equals to 0. Do you see that?
Hmm.
Cancel, then this result a equals to 0 will be lost. You get the idea, right?
Yeah.
So 15, you could always find this value, which is 4 times 16, right? 16 square, 16 times 16, right? And then
Yeah. Yeah.
4 common. Here you have a cube minus 1 equals to 0, correct?
Yeah.
So when you have this a cube, which is 4 cube here, right? 4 times 16 I wrote purposely because you could see this as like 4 cube a cube. Do you see that?
Yeah.
And clearly from here, you get your solution, which is a equals to 0. And this gives you a equals to, because this is cube root, right? So 1 over 4, right?
Yeah.
So that is how you could actually get both the solutions. But if you cancel this with this and make it 3, then
Right.
you lose one of the solutions. So you have
Right.
to be very careful when you work with these equations. It's not very difficult otherwise, okay? So that
Hmm.
is perfectly fine. How will you solve the second equation?
So can I just let like x equal to b squared? So that means b to the power of 4 would be x squared, and then just solve like a quadratic.
That is very correct. So that is correct. Remember, you only need to give real solutions. So in case you have some imaginary solutions, you don't have to give them, right? So real solutions.
Right.
So that's perfectly fine. So solving quadratic and linear equations is not a problem for you at all, correct? Next question.
Okay, yeah. There's a lot of lines. Okay, yeah.
We missed question number 3 actually.
Oh, did I? Oh, here. Right. Yeah. Integration. Okay. So, given that k is a constant, find the integral of 4 over x cubed plus kx with respect to x, simplifying your answer. And then part B, hence find the value of k such that like the integral between 2 and 0.5, 4 over x cubed plus kx with respect to x equals 8.
Correct. So this question, is it difficult for you or simple, or like, do you get it?
I think I get it because like currently at school, I've just finished integration. So yeah, but like when we're in the exam.
You remember the formula, which is x to the power of n plus 1 over n plus 1, right? So that really helps you to figure out the solution, no problems at all. And then if you know that this is the value, when we have a definite integral, you can always find the value of k. So the basic integration is not difficult for you. That is right. So let's move on to the next question. Yes.
Okay. So a tree was planted in the ground. Its height, h meters, was measured 3 years after planting. Exactly 3 years after planting, the height of the tree was 2.35 meters. And exactly 6 years after planting, the height of the tree was 3.28 meters.
Okay.
Using a linear model, part A, find an equation linking h with b.
Yeah. So how will you do?
So in terms of what's given, we could make them like coordinate points. So because we've got height in meters and t in years, those are the two variables. So instead of like x and y, just use h and t.
So t is your independent variable and height is dependent on time.
Yeah.
And so you get exactly 3 years. 3 years is the time. So when 3 years, the height is 2.35. And when it is 6 years, the height is 3.28. So the 2 points are given to us. Let's call them as A and B. When you have these 2 points, you can always find these and then get the equation. That is very clear, right? So m as y2 minus y1 over x2 minus x1. Definitely, instead of y2, y1, you're going to use t1, t2, right?
Yeah.
Those two different times, and then you can do it, right?
Wait.
Equation, yeah.
Sorry, just a quick thing. In terms of the coordinate point, you put p and then h. Is it because it's the way it's written, as in years first and
Those
then?
are your variables, correct. So basically the slope here will be equals to, as you're given here, like 3.28 minus 2.35 over 6 minus 3, right? So basically we're doing t2 minus t1 over h2 minus h1, correct? And then you're writing your line in terms of h equals to mt plus some variable c, right? Constant. That is your y-intercept, height initially, right? And then you figure out this. So once you get the equation, the second part is very simple, which is height of the tree was approximately 140 centimeters when it was planted. So that means this is the value of c, right?
Yeah.
They're saying, explain whether or not this fact supports the use of linear model in part A. So when you really solve your question, you will get some value of C. Now you have to see what is that value of C. Is it close to 140?
Oh,
so if C is close to 140, then it is okay, otherwise not, correct?
But
so
we would need to convert the centimeters into meters.
Yeah, units, you have to be very careful about. Yes, you're right. So it'll be 1.4 meters, correct?
Yeah.
Yeah.
And so approximately close to that. Yeah, okay.
You're right.
Cool.
Perfect.
Nice.
So,
yeah. Next question. Cool. Yeah. All right. So A curve has equation y equals 3x squared plus 24 over x plus 2, where
Mhm,
x is greater than 0.
mhm.
A, find in the simplest form dy dx.
Correct.
And part B, hence find the exact range of values of x for which the curve is increasing.
Okay. So first part, find the derivative of this function. Is it difficult for you or simple?
Simple.
Very simple, right?
Yeah.
So derivative, as you can see, is 6x
6x
minus 24 over x squared, correct?
x squared. Yeah.
That becomes your derivative. And you can always write it, this is quite simple form. Hence, find the exact range of values of x for which the curve is increasing. So how will you find what is the range for which the curve is increasing?
Is that where the first derivative is greater than 0?
Correct. So now you have to see when is the first derivative greater than 0, and you know x is always greater than 0. So you can make that interval table and check the values where it is greater than 0 and get this solution. Correct? So that
Mm-hmm.
should be difficult for you.
You need to find any stationary points or anything.
Yeah, because
And then
well,
you look at either side of the stationary point.
yes.
All
So
right.
first thing is you'll equate this to 0, right? So
Yeah.
first thing is you'll find a critical point, right? And
Mm-hmm.
then analyze. So when you equate this y dash equals to 0 to find the critical point, right?
Yeah.
Which is 6x equals to 24 over x squared, correct? And
Yeah.
then this can be very easily simplified because x is greater than 0. You can cross multiply. So you get x cubed equals to 24 over 6, right? Which is 4. And therefore,
Mm-hmm.
x is cube root of 4, right?
Yeah.
So you need to analyze from the interval from 0 to cube root of 4, right? And then the interval, which is from cube root of 4 to infinity.
To infinity.
And then when you do that, you may get this as positive, that as negative. If that is positive, then this is the interval where it is increasing. You get the
Yeah.
idea?
Yeah.
So that is how you're going to solve this.
Perfect. Okay. Wait, so you wouldn't use like second derivative or anything
You
because
could,
that's not.
you
Oh.
could, that's a brilliant thing. So once you find that the first derivative for this is 6x minus 24 over x squared, right?
Mm.
You could find the second derivative also. Second derivative does help you to find the concavity, right? Remember,
Yeah.
so when you find the second derivative, which is in this case 6 minus, and then you get 24, and this is minus 2, so minus 2 and 1 over x cubed, right? Something like this you get, right? Now, the question says increasing interval. Curve is increasing. Now, remember
Yeah.
one thing, that when you're saying increasing interval, in that way, this is not required.
Okay.
Second derivative is only required when you're looking into concavity or point of inflection. Is it okay?
Yeah.
For increasing interval, you need to analyze first derivative only,
Okay. Yeah.
right? So that is what it is. So don't do second derivative for this particular part of the question. Is it okay?
Yeah. Because it says increasing. Yeah.
Next.
Okay. Figure 1 shows a sketch of a triangle ABC with AB equaling 3x centimeters and AC equaling 2x centimeters,
Mhm.
and angle CAB equaling 60 degrees.
Correct.
Given that the area of the triangle ABC is 18 root 3 centimeters squared, part A, show that x equals 2 root 3,
Correct.
and part B, find the exact length of BC, giving your answer as a simplified surd.
Perfect. How will you do this question?
Okay, so since we are given side angle side,
Mhm.
we can use the cosine rule to
Okay.
find BC.
Cosine to find BC.
That one is called.
Well, why do you want to find BC? Not required.
Oh, that was for part B. Oh, sorry. Never mind.
Okay, what is part B? Hence, find the exact value. Okay, that's fine. Hence, find the
Sorry,
exact
we're
value,
looking at part A. I
which,
don't know why I said that.
which you can find after finding value of x. Well, here is something, Amy.
Mm.
They've already given you part A, which is show that x equals to 2 square root 3, correct?
So we're already given what X is.
If you do not know part A, let us say,
Yeah.
then you can use the value of x as 2 square root 3 and find BC using the cosine.
Yeah.
You could do that, at least you get 3 marks. Do you get the idea?
Yeah. Don't just ignore it just because it's a following part.
Yes,
Usually people think that you can't do part B without knowing part A. But
yes.
if part A helps you, then use it. So
Use
yeah.
and then figure it out. Even if you do it and you get a different answer, you may use x equals to 2 square root 3 and do part B.
Mm.
Get my
Okay.
idea? Because
Yeah.
you cannot repeat your mistakes. If something went wrong in your calculations. Now, let's get back to part A. How will you do part A? Tell me. You are given the area.
Yeah. So I actually have two ways. So can I just say either? So when I looked at this initially, I was thinking half AB sine C, and then making that equal to 18 root 3. But I realized that's just a lot going on. So what we could do is split it like that, and then use our perfect triangle and do is it sine 60 or cos
Right.
60? Or just any of those,
Yeah. So
because we know exact
half
values.
AB into the height h. This is what you're trying to say. And the value of h, if you look into this particular triangle, is equals to 2x sine 60, right? H equals to 2x sine 60, correct?
Yeah.
Okay. And as soon as you see this, you know a special triangle, which is 30, 60, 90 triangle, correct? So in 30, 60, 90 triangle, the sides are 1, 2, square root.
2 and root 3. Yeah.
So clearly from here, when it is 2x centimeters, you already know this height is root 3 times x, correct?
Mm-hmm.
But you could do here also, right? This is like square root 3, that is a value, over 2. So you get square root 3 times x as the height. And once you know base and the height, you know the area, correct? So area is given to you as 18 square root 3. So 18 square root 3 is equal to half of base, which is 3x, times the height, which is square root 3x, correct?
Mm-hmm.
So from here, you can find the value of x very easily. And you'll get this value of x as asked for. Is that clear to you?
Yeah.
Perfect. And that is how you could do it. And of course, you also know that using this cosine law, you have a general standard formula also, because height can be written uh, as this side AC sine of the angle theta, right? So you could
Yeah.
use the standard formula, which we have for finding the area of a triangle where the included angle is given with two sides. Okay, so review that part. So what you need to review here is cosine law area formula.
Mm. Cosine law area formula.
Because you have in a way derived in this particular case that instead of this, if I have general theta as the angle, for example, is that okay?
Yeah. Yeah.
So in that case, the area will be half AB into what? Height, right? Height is AC sine theta, right? So this is your general formula.
I'm actually kind of confused why height was 2x times sine 60.
Okay, what is sine 60 equals to? Sine 60 equals to height over 2x. Is that okay? Height over 2x. So height is equals to
O over height.
opposite over, yeah,
Yeah.
opposite over hypotenuse, right? So
H
A
over 2x. Yeah.
times sine 60. Is that clear to you?
Oh, yeah, you worked really quick. Sorry, you missed us.
No
Yeah.
problem. So
Okay, cool. Yeah.
here is a cool thing. The general formula when this thing is there is this. So it is half of AB AC sine theta.
Mm-hmm.
Half of AB, this side, the other side, and this height is sine theta, right? Related to sine theta. So that is how we get a direct formula in such condition to find the height of the triangle. Is it okay?
Oh, right. Okay. Yeah.
Yeah. So, okay, let's move on to the next question. I'll put the battery here. This computer is getting need charging. Okay. Next question.
Okay. The curve C has equation y equals k squared over x plus 1, where x belongs to real numbers and is not equal to 0, where k is a constant.
Correct.
So part A, sketch C stating the equation of the horizontal asymptote, and line L has equation y equals minus 2x plus 5.
That's the second part. Yeah.
Yeah, so show that the x coordinate of any point of intersection of L with C is given by a solution of the equation 2x squared minus 4x plus k squared equals 0. And part C, hence find the exact values of k for which L is a tangent to C.
Good question. Very good question indeed. So how will you solve this question?
Okay, so usually if I just looked at it, you always told me to look at like the restrictions. So in terms of restrictions, we know x is not equal to 0 and has to belong to real numbers.
Yes.
And that makes sense because it's a rational function, so you can't have like 0 at the bottom.
Right.
So sketching C and stating the equation. Okay, so in terms of, so like when I think of graphs, when I like did graphs and transformations with you, you said usually the 1 over x1 would be like, I think I can annotate,
Yeah,
so let me just quickly show. All right, cool. So if it was 1 over x, usually it's like that.
Right. Perfect.
So it doesn't really matter what k is since that's just a constant. But the plus 1 thing would mean that the whole thing shifts up 1. So you have a horizontal asymptote at y equals to 1.
Correct.
Yeah.
Right. Since there is a horizontal asymptote, we'll re-sketch this particular graph, which you just sketched, which is perfectly fine. So what you're trying to say is kind of like this, right? So first thing is we'll sketch the horizontal asymptote, which is at 1, right?
Yeah.
Since k square is always positive, so why k square is with the purpose, it is always positive. So you do have a graph which will be kind of like this, correct?
Oh, cut the x-axis on the other side. Yeah.
So that becomes the graph for the function, and you have to give the equation of horizontal asymptote, which is y equals to 1, which you get directly from here, correct?
Right. Yeah.
So we have sketch C stating the equation of horizontal asymptote. So that is what we've done, right? So you write x and y on this side, and you're done with it, right? Now, the line L has an equation y equals to minus 2x plus 5. Show that x coordinate of any point of intersection of L with C is given by this. So how will you do this part?
Can I quickly draw a line?
Okay.
Oh no, I mean theoretically, y equals minus 2x plus 5. So you would draw it on the graph, and you would see it would be going down.
Yeah, it is going down. So your line is like this. We don't know the value of k. So your line could be kind of like this, right? It could be kind of like this. It could be kind of
or it could not touch. Yeah.
Yeah, basically, this line is fixed. What I'm trying to say is because we don't know the scale of the drawing, correct? Our line is fixed. Let me just redraw this clearly. Right. So let's redraw so that we have more space in quadrant 1. Most of the things are going on in this quadrant, so it's good.
Right.
So the real thing is that we have a line whose equation is given to us. So this is the line which is, let us say this point is 5 and it has a slope of minus 2, right? So when y is equal to 0, we get this as 5 by 2.
Right.
5 by 2 or 2.5 as you may write. Is it okay? Now, the thing is that we have a graph which we are drawn like this. Okay. Our graph on this side could have been like, is that clear to you?
Is it hitting it at 2 points?
May or may not, because this value, this depends on the value of k.
Because it could hit 1 point, 2 points, or none.
K is a vertical stretch factor. Do you see that?
Yeah.
So this vertical stretch factor may actually bring it to a value also, which could be kind of like this. Do you see that?
Oh, right. Yeah.
Or that factor could also make a graph which is kind of tangential
Bit
to it.
more. Yeah.
That really depends on the value of k. And that is why we have the second part to this. Is that okay? But
Mm-hmm.
anyway, whatever the value of k is, you can always see how or what are the points where they interact, right? So,
Mm.
so that x coordinate of any point of intersection of L and C is given by this, basically means you will equate the two
Solve it.
equations, correct? So say minus
Yeah.
2x plus 5 is equals to k squared
Equals.
over x plus 1, correct? And when you
Yeah.
do this and solve, what you get is the equation given to you, correct?
Yeah.
Bringing all the terms together, that is what you're going to get, right? Now, in this
Mm-hmm.
equation, at this time, we'll focus on the value of x greater than 0. Reason being, from the diagram itself, it is very clear that the value where this line could intersect the graph, it was
It's
only
right.
quadrant 1, correct?
Yeah.
In quadrant 1, x is greater than 0, and therefore I could cross multiply and solve it in this fashion. Do you see that?
Yeah.
So
Yeah.
you should provide that reason, otherwise you might lose some communication marks.
Oh,
You
right.
cross multiply, right? And then you say,
Mm.
well, this is minus 2x squared plus 5x equals to k squared plus x. Do you see that?
Yeah.
And then you'll bring them together to get your equation. But why did you multiply every term by x? I
Because
mean,
X has to
this is
be.
also an equation, it can work. It will work even otherwise. That's perfectly fine. This is not an inequality. So it's an equation, it works either way. Perfect.
Mm. Mm-hmm.
Anyway, it's a good thing to understand that your point of intersection is in quadrant 1. Is it okay?
Yeah. Yeah.
Because the line is in quadrant 1, not in quadrant 4. Correct? Not in quadrant 3. Right? Not in quadrant 3.
But
Okay.
if it was in if it
Yes.
was in quadrant 3, then what would happen? The X values would be negative.
Yeah, yeah. You don't have to take x value as negative in your answer.
Right. Yeah.
Yes. Correct. So your x value is greater than 0. Now,
Mm-hmm.
so you got this. How do you get part C?
Um,
Can you please
find the
read it?
exact values.
Okay.
Yeah, for which L is a tangent to C. So by tangent, you're saying it only hits once on the curve.
Got it.
So, so, um,
So when it is
I don't
doing
know.
tangent, then you remember the discriminant b square minus 4ac in a
Mm,
quadratic equation? That
it
should
has
be.
to be equal to 0.
So solve this equation with the discriminant b square minus 4ac equals to 0.
Oh,
You understand? And then
mm,
find the value of k. K value could be any value, right? This is k
yeah,
square. Even if it is negative, it will make it square, it will be positive.
positive. Yeah,
So you can find the value of k using b square minus 4ac, which is 6b square minus, use this value and then get the value of k.
yeah, yeah.
You can do that part. So the important thing here in GCSE examination is that questions are related. Each part is related to one another. And therefore,
Mm-hmm.
you have to be very careful how to use the information which you have already got to get further solutions. Is that clear?
All right. Yeah, yeah.
But that also tells you a hint. That is, if you don't get the previous part, use those values to get further solutions.
Oh, okay. Yeah. Don't
Because
just like stop there. Yeah.
don't stop. You at least get the later half, right? Do you see that?
Right.
So I think
Mhm.
this is absolutely clear, but beautiful question where you need to review how to sketch graphs, the rational functions, the quadratic functions also, correct?
Yeah, yeah,
Let's move on to the next question. Yes.
yeah. Okay, 8a. So find the first 3 terms in ascending powers of x of the binomial expansion of 2 plus 3x over 4 to the power of 6, giving each term in its simplest form.
Correct.
And then part B, explain how you could use your expansion to estimate the value of 1.925 to the power of 6, and you do not need to perform the calculation.
Perfect. So how will you do part A?
Part A. So when I look at that, because this is binomial expansion, I guess there are 2 ways, but the one that comes to mind is like Pascal's triangle.
Pascal's
Um,
triangle. Okay.
yeah, so I'll just find the constants for row that has 6 in it, and then just find the first 3. Or you could
Right.
do the NCR thing as well, using a calculator. Yeah.
Using calculator, that's a brilliant idea. You could do NCR thing also, right? So you know the first term is 2, right? And you know n is 6. So we have 6c0,
Yeah.
2 to the power of 6, right? This is your first term.
Yeah.
6c1, 2 to the power of 5
5
times 3x
times 3x over 4
plus 6c2, 2 to the
times
power of 4
4.
times
Yeah.
3x over 4 whole square, right?
To the
You
power
can
of
use
2.
this choose 6 choose 0 6 6 choose r and use calculator to figure this out. Correct. So you get the first 3 terms as shown here. Correct. That is perfectly fine. So you get your idea. The important thing here is if the value of x is less than 1, then as the number of terms increases, I mean the power increases, the value decreases and it can be ignored.
Right.
That is why in many questions we are focusing only on first few terms, right? Now,
Um,
how will you answer part 2 of this question?
okay, so looking at that, you would see we're trying to find some similarities. So in terms of what's given, so the 2 plus 3x over 4, that has to equal the 1.925 because those two things are to the power of 6. So then you'll do 2 minus the 1.925, and then the value that you make it equal to the 3x over 4.
That is over 4, correct?
Find x, and then just sub it in.
That is beautiful. So find x and sub it in here, right? So that is great. So that is how you're going to find the value. Perfect. And we ignored the rest of the things because in this particular case, you can say approximately that is the value which it will be because it is 2 minus some value. Is that okay?
Right. Yeah. Yeah.
So that is beautiful. So that is correct. Perfect. So you do remember, it's great that you remember binomial expansion,
Pascal's
Pascal
triangle.
triangles, and so
Yeah.
many other related things. Good job. Next, please.
Thanks. Okay. This one.
Yeah.
A company started mining tin in Riverdale on the 1st of January 2019.
Mm-hmm.
A model to find the total mass of tin that will be mined by the company in Riverdale is given by the equation equals 1,200 minus 3 n minus 20 whole squared, where T tons is the total mass of tin mined in the n years after the start of mining.
Correct.
So using this model, part A, calculate the mass of tin that will be mined up to the 1st of January 2020.
Mm-hmm.
Part B, deduce the maximum total mass of tin that could be mined.
Yes.
Part C, calculate the mass of tin that will be mined in 2023.
Mm-hmm.
And D, state giving reasons the limitations on the values of n.
Okay. So how will you approach this question?
Okay. So for part A, calculate the mass of tin that will be mined up to the 1st of January 2020. So
Yeah.
since it's only like a year after, you would make n, which is the number of years, to make n equals to 1, put 1 into the main equation, which is that one, yep, and then just
Find this. Correct.
find, yeah. Okay, part B, deduce the maximum total mass of tin that could be mined.
Mm.
Mm-hmm. Would you make T equals to
So
no?
you have a graph here, right? And you want to deduce the maximum total mass of tin that could be mined in all. Do you understand?
Mm-hmm.
So basically, if you look at this particular graph, what kind of graph this is? This is a parabola, right? Which is opening downwards, right?
Right. Yeah, because it's minus. So it's like
This
this.
part is always positive, so 3 times some positive number, but it is opening downwards. And the peak is at 20, 1200, correct? So 20 years from now, it will give you a maximum. Do you get me?
Mm-hmm.
So if you
Yeah.
sketch this particular graph, for example, in that case, your graph may be, if you put n as 0, In that case, it'll be 1200 minus 3 times 20 square, correct?
Yeah.
Equals to 0. Then you can find the initial value, which is 1200 minus 3 times 20 square, correct?
Mm-hmm.
So 20 square is 400. So it is 1200. It is kind of 0, right? So you just started mining.
Yeah.
Is kind of a parabola like this, right? So in this parabola, you will notice that this maximum value occurs after 20 years and the value is 1200.
Oh, okay. It's
And
all about making n 0.
this will
Yeah.
be, from symmetry, this will be 40. So you
Right.
have an approximate idea of this particular graph. Is that clear?
Yeah.
Now you say deduce the maximum total mass of tin that could be mined. That means you need to find area under the curve.
Oh.
So this is integration. Do you see that?
Oh.
Where
Yeah.
the
No,
limit
I
is
wouldn't
from
have got
0 to
that.
40. Yeah, it's a very beautiful question. So then you have to integrate the curve, which is polynomial basically. And to integrate this will be easy for you to expand this, correct? Expand and integrate. Okay, is that okay?
Mm-hmm.
And you can use the power rule, correct?
But how do I know where it's in between? Do I need to find the root?
Which in between? From the
Like
symmetry of the parabola.
the
The one,
values it crosses the x-axis.
you know it is 0, right? At
Oh,
40,
and 40.
it's a parabola.
Okay.
You can
Yeah.
find it. You can calculate. How will you calculate? Well, you know this is 0, right? You can solve the equation. 0 equals to 1200 minus n minus 20 whole square, if you want to do like this, right? So 1200 goes that side, then you square root, and then you add 20. You get the idea?
Okay. Yeah.
So you could solve it 3 times, I'm sorry, 3 times, right? So you could solve and you'll get these two values. So you'll say, well, 1200 divided by 3, and then you do square root, correct? Equals to n minus 20. Is that okay?
Mm-hmm.
And when
Yeah.
you square root, you have to do plus and minus because you're doing square root, right? So this is 400. 400 squared is 20. You get 20 equals to plus minus h, right? N minus 20, right? And
Yeah.
therefore, you get the value 0 and 40. Do you see that? You could do
Yeah.
like this. Or
All
you
right.
can do analysis, just as we did, right? Do a
Mm-hmm.
parabola. So basically, you need to integrate from here 0 to 40 the function. Is that okay?
Yeah.
And then you get your answer. So that's a very beautiful question, and that's how you're going to do it. Now, part C is calculate the mass of tin that will be mined in 2023. So how will you do this question?
Can you just sub in n as 4? Or
Okay.
no?
So 2023, of course, it is 4, but in that particular year, you get the area. So you calculate, sub it in 4, calculate a value, and also 3, calculate a value and their difference. Mined in this year.
Oh.
So better way will be, you should integrate from 3 to 4. Do you understand?
3. Yeah. Yeah.
So in that case, if you have that integral, then you integrate from 3 to 4 to get this value of this function. Is that clear to you?
Mm-hmm.
So you get how much was mined during that year. Is that okay?
Wait, how come the area under the curve tells you the total mass of the tin? Like,
Because that is what mass is. The total mass will be given. This T gives you the amount of tin mined, right? So this is T, right?
oh, okay, okay.
So that is how it gives you. Is that clear
So
to you?
any value on the t, any value on the y-axis, I mean,
There's
will always give you the area under the graph.
Yes, integration means sum of, right? Integration is
Oh,
basically sum of, right?
okay.
So
Yeah.
when you do that integrated, as you know, from the integral which we learn, you remember how initially we started with the different, integrating curves using these bars. Do you remember that?
Uh,
Center
oh,
and
yeah, yeah.
So when I taught you integration, we looked into the Newton's laws,
Mm-hmm.
the fundamental theorem of calculus. So you need to review that fundamental theorem of calculus.
Yeah,
How integration relates to the area, right?
yeah, yeah.
So that will help you to understand this part. Is that clear to you?
Yeah.
Now the last part is state giving reasons, the limitations of the value of n. So of course n is 40, right? After that there is nothing left, right? Your mind
Yeah.
is for this particular equation, correct?
So that's the limitation, because if you do values after n, there'll be
Yeah.
nothing. It'll still be 0.
Correct. Okay, so let's move on to the next part.
So is it just trying to say that n can't be negative, or?
So n, from the equation, you could say n could be anything, but this value has to be less than 1200 because t is positive, right? Do you see t has,
Right.
you're mining something out. You cannot put something in.
Negative.
It cannot be
Yeah.
negative, right? At the most, it could be 0. You don't have any tin there left, right? Because
Right.
you mine everything out, correct? So you
Mhm.
have an inequality to think about, right? So of course, whenever it is like our graph was like this, we know after this it will go down, but it cannot. So that
Yeah.
is the limitation. Is that okay? After
Perfect.
that, there's nothing to mine. Why will you mine, right? Okay.
Yeah.
That is what
Okay.
the idea is.
That's right. All right. Okay, so a circle C has equation x squared plus y squared minus 4x plus 8y minus 8 equals 0. Part A, find the coordinates of the center of C,
Okay.
and part II, the exact radius of C.
Yeah.
The straight line with equation x equals k, where a is a constant, a is a tangent to C. The
Right.
B, find the possible values for k.
Yeah. How will you do this question?
So when the circle equation is given in that form, I kind of just know that when you want to find the center, it's could I just quickly write down, otherwise it wouldn't make
Yeah.
sense.
Write down.
Okay. You know, when it's in this format where you go x squared plus y squared plus 2fx
Mm-hmm.
plus 2gy
Correct.
it's plus c
Mm-hmm.
equals 0.
Correct.
The 2f basically equals the minus 4,
Perfect.
and then the 2g equals the 8.
Correct.
So when you want to find the center, it would be the minus f minus g.
Yes.
So whatever values you get, you have to invert it to get it to this. And then for the radius, you do f squared plus g squared minus c.
Perfect. That is perfect. Good. Good. You remember a lot. So what is the value? Minus f minus g in this case. What is the center value? Tell me.
Okay, so it's 2 minus 4.
Perfect. So that becomes the center. And what is the radius?
So it'd be 2 squared, no.
Yeah, 2 squared.
Oh, 2 squared plus 4 squared, 16, plus 8. Square root of 28.
Plus 8.
Oh, because it's minus 8, it just, yeah.
So you get this value, which is 28 square root, right?
Which
7
is
times 4. 7 times 4 is 2 square root 7, correct? Radius. 2 square.
2 root 7.
Very fast you have solved this particular question. That is extremely efficient. I really appreciate it.
Oh,
Now, there is an alternate method also, which is like completing the square. And you had actually done completing the square to find the answer. Do you remember that part?
yes, yeah, definitely.
Right? So you could complete the squares here also. You could use x squared minus 4x. And you know, this is twice. So that means plus minus, we have to add 2 square, right? Both the sides.
All right, yeah.
And you could do. So you could use complete the squares also. However, this is perfectly fine. So once you do this, you know the radius, you know the center. Now, how will you do part B? Read from here.
Straight line with equation x equals k, where k is a constant, is a tangent to C. Find the possible values for k.
Yeah, how will you do?
When they say x equals k, it's a vertical line.
Perfect. X equals to k is a vertical line. Correct.
So if we had, so we know the center. So if you could do like a quick rough sketch. So if you draw the axes and you put 2 minus 4 as the center and just quickly draw a circle, Yeah,
Okay.
like that. We know that the tangent, because it's a tangent, it can only hit at 2 points, and the vertical line will only hit twice on the circle. So it
Yeah.
either could be on that side or it could be on the right-hand side. So we know, yeah, so we know the radius.
Yes.
I was thinking, I don't know if we could find the gradient and then the
No,
tangent would
2
be the
plus
normal.
radius. And this value of k will be equals to 2 minus radius.
Oh,
Because on the either side, it's just a horizontal line. So those are
yeah,
two values of k. Do you get it? And
yeah.
making the sketch really is a very efficient way of solving. That's beautiful.
Oh, okay. So I kind of messed up on that. Yeah, yeah. So looking at the diagram, that makes it clear because you can see it's 2 this way and then 2 that way. All
Yeah.
right. Yeah. Okay.
Next
I
one.
definitely recommend diagrams. I'm a visual learner, so I need diagrams. Okay.
11.
Sorry, what happened?
11.
Oh, it's here. Okay. Okay. So fx equals 2x cubed minus 13x squared plus 8x plus 48. Part A, prove that x minus 4 is a factor of f of x.
How will you do this part?
So I was going to take the function f of x
Yeah.
and then divide that by x minus 4.
Correct.
And then if you get the remainder as 0, it means that x minus 4 is a factor.
Yeah. So you can use synthetic division also if you want, correct?
Yeah.
You're good at synthetic division, divide by 4. And if you get this remainder as 0, that means a factor, correct?
Yeah.
Perfect. And that is how you're going to do, right? So you just bring down 2, 4 times 2 is 8, add them up, right? So you get minus 5. So minus 5 means 20 with the minus sign. And then you add this up, you get 28. Sorry, 12, right? Minus 12, when you multiply by
Minus 12.
4,
Yeah.
minus 12, you get minus 48, and you get 0. That's
Yeah.
it. So you have this quadratic function, which is 2x squared minus 5x and
Minus 12.
minus 12. So that is the other factor. Is that clear to you?
Yeah.
One factor is this is the other factor. So yes, we have done the first part, remainder being 0. This is a factor. Now part B.
Okay. Hence, using algebra, show that the equation f of x equals 0 and has only 2 distinct roots.
Okay, that means you need to factor this also, right? So can you
Yeah.
factor this? Tell me what is the factor for this? 12
Um,
times 2 is 24. You need to find 6, 8, and 3, right?
8 and 3. Yeah.
2x squared minus 8x plus 3x minus 12. In this 2x is common, right? So you get x minus 4. In this 3 is common, we get x minus 4. So x minus 4 is again a factor. Do you see that?
Right. So we just proved our first point.
Yeah, so it says, well, the real factors are this, and earlier we already had a factor, which was x minus 4, correct? And therefore,
Also, the
there are only
x.
two.
Yeah, so I was saying, because when we learned about graphs, you know, when we did our degree and we said because the x minus 4 comes up twice, we know it has to be a quadratic
Turning
thing, and
point.
that makes
Yes.
sense. Yeah, since it's coming up. Yeah.
Perfect. And this point happens to be then minus 3.
Minus 3 over 2. Yeah.
Perfect. So this graph really matches with all our calculations, right?
Right.
When you sketch, you get this particular graph. So you can move up, see what is part C.
All right. So figure 2 shows a sketch of part of the curve with equation y equals fx. Deduce giving reasons for your answer, the number of real roots of the equation. This.
Yeah. So
So
compare
this
this
is
equation with the previous one. What is the difference?
a difference of, oh wait, it's really hard to get on the same page. So this one says 48 and that one says 46.
Correct. So that is 2 less, right? This is 46. Okay.
Yeah.
So then how will this change when I change this from 48 to 46?
So it's moved, the graph has moved down 2 units. So vertical translation down. So it crosses the axes 3 times.
That is so true. It will now cross the axis 3 times. Yeah, move your question. Let's see what is being asked in question number C. Yes.
It just says giving reasons, calculate the number of real roots.
So there'll be 3, right?
Yeah.
The reason is, as you said, it gets translated down. So earlier we had a double root at x equals to 4. Now we'll have, instead of that, 2 roots there. So 3 in all. Correct.
Yeah, just a quick thing. When we did similar things at school, like most of my like friends and things, they, if a question came up like this, they would start to solve this one and find like roots and like so much drama. If you can see the resemblance between the two and just realize that it's a translation, your life's so much easier. Yeah.
Correct. So you need to use the information about transformation, right?
Yeah.
Which in this case is simple vertical translation.
But sometimes in the moment you don't realize that. You just go straight into, oh, it's a cubic thing, let's start factorizing, let's do that, and you just go into that without even just stopping to consider it could be something else.
Correct.
All right, so part D, given that k is a constant and the curve with equation y equals fx plus k passes through the origin, find the 2 possible values of k.
Yeah, what could they be?
Okay, so in terms of what the translation is, it's a horizontal translation. So k could be, obviously it's just a constant, so it either could be shifted, because we got 2 roots, it could be shifted to the right by, we know that that point there was minus 3 over 2. Yeah, so we by 3 over 2, and then minus 4. Yeah.
Perfect. So easy, right? So it's a very difficult question. Actually, it's just not that simple. It requires a lot of information or knowledge about transformation. So you have beautifully solved this particular question. And I think you, with this paper alone, you have reviewed previous so many chapters. You see, everything comes fresh in your mind. You see that? So basically, what are you doing here is you're exciting your neurons and you're making your brain work so that it could extract the information which has been hiding there, sitting there over a period of time.
Yeah.
So going through the test paper helps you to really get ready for preparation. Now at this stage, when you start your review, you will understand what are the major areas to focus on when we are reviewing, right?
Yeah.
Chapter, what is expected to be asked in the test, correct? Those things are very important. And therefore, before you review, do some test papers, right? At least 2 or 3 of them, so that you have a framework in your mind. Well, when you're doing this particular chapter on linear equation, for example, you should be very clear, how can I see the equation of the line, both as slope form and also picking up normal from the line itself, saving it. Do you see that?
Yeah, yeah, definitely.
These are very important things. As every chapter will give you a hint. Quadratic equation, we have to analyze the discriminant because the question could be related to it in that particular fashion as we have.
Right. It's so interchangeable and so interlinked. Yeah.
So let's move on to the next question.
All right. Okay.
I saw that was a trigonometric equation earlier. You skipped that, right?
Oh, did I?
No, continue. Not it.
Okay.
Yeah.
All right.
Okay. Show that 10 sine square theta minus 7 cos theta plus 2 over 3 plus 2 cos theta equals to 4 minus 5 cos theta. How will you do this?
Okay, so when we actually did this, you always stated how we always start with the left-hand side and make it equal to the right-hand side. But before starting, you look at the right-hand side and see like in what terms it is in. So, for example, this one is in terms of cos. So cos theta. So like, let's make everything on the left-hand side in terms of cos as well. So using our trigonometric identity being sine squared theta plus cos squared theta equals 1, we know that sine squared theta equals 1 minus cos squared theta. And then you just sub it in where you say sine squared theta, and then hopefully you'd get
quadratic equation in cos squared theta. You can factor, and then you'll get the right-hand side.
Right.
And what you are expecting is probably one of the factors 3 plus 2 cos theta that cancels away. You see that? And then you're left with the right-hand side. And that is how you will prove that left-hand side is equals to the right-hand side. Is that clear to you?
And that's a nice way of checking, isn't it? Because we know that it has to, we know that one of the 3 plus 2 cos theta would be a factor since it gets cancelled in the
That is
answer.
true, right? And when
Oh,
you
okay.
visualize, you actually see the solution in itself, and that
Yeah.
helps you to gain confidence and attempt the questions. You get the idea?
Oh,
Can you do
okay.
part B now?
Yeah. So hence or otherwise solve for x, which is between 0 and 360,
Yeah.
but 0 is included, the equation 10 sine squared x minus 7 cos x plus 2 over 3 plus 2 cos x equals 4 plus 3 sine x.
How will you do this?
Okay. So since we found out, so the whole thing on the left-hand side of that is equal to 4 minus 5 cos theta.
So here you write 5 cos x, correct? Because the equation is cos x.
Oh, yeah. Instead of theta, they put x. Okay.
Simple as that. Correct?
Oh, okay. And then we know the other trigonometric identity, which is sine theta over cos theta is tan theta.
So I bring 4 here, so you get 4 minus 4 equals to, anyway, or you just cancel 4, right? So we got this 5
Oh,
cos
yeah.
x sin x, you can divide by cos x, that's what you're saying, right? Because 5 over 3 equals to sin x over cos x, correct?
Get and yeah.
Which is tan x. That's what you're saying, correct?
Yes.
Now, how will you find the solution?
Can I use a calculator?
Okay, use the calculator, you're right.
Oh, can I? Okay.
Tell me the solution.
Yeah, I was just gonna. Oh, okay. So if I do tan minus 1 of minus 5 over 3, you get minus 59.03.
That is not in the domain.
Right.
So that is not the answer. So what you have to do is related
180.
acute angle. Do you understand?
Oh,
Since the
to the
answer,
cos rule.
yeah, since the answer is negative, you expect the solution to be in quadrant
Um,
and 4, correct?
3. Yeah, yeah.
Because
2 of
tangent is positive in 1 and 3. So you'll find this related acute angle beta. Do you understand? You will say tan beta, or you can say tan inverse of 5 over 3. 5 over 3 is beta, right?
Oh, okay.
Now you find what is tan inverse of 5 over 3.
59.
Let us say
Right.
59, right?
Yeah.
So in that case, the solution will be 180 plus minus 59 degrees
And
and
plus
360.
360 minus 59.
Do you understand? So those
Oh,
are the
okay.
two solutions, and that is how you're going to solve this particular question, correct? So I
So
think,
when we,
yeah,
sorry, but when we did the minus, so when we found out that it was minus 59,
yeah.
if we write, so it's either in where you wrote 2 and 4, do you just put it, so that, okay, so that angle there is 59, and then the one that you highlighted there is also 59.
Correct.
Oh,
You get the
okay, I
idea.
see.
So when you use your calculator, the calculator gave you minus 59. However,
Yeah,
minus 59 is not in the domain.
yeah,
You use that as your beta also, which we finally got the same thing. You get the idea?
yeah.
The whole idea here is whenever you're trying to solve a trigonometric equation, find the related acute angle, figure out the quadrants in which the function could be, and then provide all the relevant solutions. Is that clear to you?
Right, yeah,
Calculator can only give you one value, and sometimes that value is not in the domain as
yeah,
it was in this particular case.
right.
So I think we'll end here. You're very good at all those things which you've done so far. Few things which you need to do, review is, you can recall from here, work slightly more on trigonometric equations that need more thought process, right? The
Yeah,
integration
definitely.
questions which we saw in this particular test paper were relatively simple, and therefore you got them very easily. One of them was a bit tricky to find the area under the curve, which was difficult to understand. How do we find the total mass of the tin, right? So whenever it is the total of the area, it
Yeah,
is basically integration. So that is the concept. So what is really integration? On so the curve, area under the curve, right? So
yeah.
that, so that is a very good thing, and it's very good
It's
to see.
because, yeah, it's because that question was so immersed into quadratics, and you know, when I'm thinking quadratics, I'm always thinking like the maximum and like all these questions. I didn't think of bringing integration in.
Yeah.
I just completely blanked it out. So I was trying to find other ways of trying to figure it out without integration. So it didn't even like click onto my head that you could merge those two. So yeah.
That is so true. So Amy, we can end the session now. You can stop sharing, and then we'll discuss what are your thoughts about how do we review the test paper. So what do you say after this? How should you review for your final exam?
Okay, so definitely don't do what I started off by doing, by going through this big book of
Mhm.
just like looking at questions in here, trying to like start doing examples in each chapter, which honestly didn't like make anything go into my head, since I knew questions that were coming up in the chapter since I was in that chapter.
Yes.
So that's not the way to revise. So however, like you said, sir, take up a past paper and flick through it and like do what we were doing, not even trying to figure out the exact answer of each question, just to run through it in my head to see if I remember it. Do I recall anything, any equations? Does it come to mind? Just like you said, make those neurons to start working, which I haven't actually done. That's why I'm finding it hard and it's not like coming as easily for me. So
Yes.
definitely to review, you need to get an exam paper, you need to look through it quickly, like run through and see if you can remember a few things, and that will tell you whether you know, or like how strong you are at some topics and how you are not as strong as like in others. And then from there you go to that section and then you start revising that particular point where you're weak at.
Perfect. So this is the approach. So finally,
Yeah,
pick up at least 5 previous test papers.
yeah,
Once you
okay,
pick up 5 test papers, just go through it. Just don't sit there and solve them. Go
okay,
through the strategy of solving them.
yeah,
Make your points, right? So make your point. Equation, standard form of circle equation. From here, how do we read the value of center and the radius? It's very difficult
right,
question otherwise,
yeah,
right? You
yeah,
remember, and therefore you could actually do it, right? Then, how are the questions related? We may begin with a linear equation,
hmm,
do derivative of this, and then an integration. So
yeah,
every question actually is a compound question where every part
right,
takes you from one chapter to the other
to the
chapter,
next,
the next unit sometimes, right?
yeah,
Altogether
yeah,
different story. Do you see that?
yeah,
Ano- Another important thing is, since you have learned very high level concepts of calculus and vectors, you could actually apply these concepts even in solving simpler questions. Do you see
yeah,
that? So when
yeah,
we see the equation of line in standard form, we of course can read the slope by interchanging and writing them in slope intercept form, but we can treat this as a normal form or Cartesian form of the line equation. And we
yeah,
can
yeah,
actually pick up the normal from there directly also, right? That
hmm,
helps us to even check our solution at times. You get the
right,
idea.
right,
Now, one more thing which I saw here is that your formula list is not ready. So when you go through your chapters, make your formula list so that you have
hmm,
all the formulas in place. We had a question where we wanted to find area of a triangle where two sides and angle was given to you. So when you
yeah,
use cosine law, in that chapter itself, you learn how do we find area of triangle using sine law and cosine law, correct?
right, yeah,
So that particular formula is very useful, and I've seen that kind of a question many times in the test paper, right? So
hmm,
we had two questions from trigonometry, as you could see, and they were quite difficult questions in all, right?
yeah, yeah,
So, so I think the chapters which need to be more laid stress on are definitely calculus. Vectors, we did not go further into the test paper. I'm sure there must have been a few more questions on vectors also.
yeah,
So calculus part is very heavily there, but the other parts which students think that they are very simple actually are 80% of the test paper, right?
yeah,
And they are very much correlated. So don't ignore them.
definitely. Yeah, because you think that they're easy, and then you don't just think about it again because you're like, oh, that's easy, I can do it. But then when it comes in, those are the small things that you can just slip up on. Even like simple things like, you know, indices, and when you have to when to add them, when to multiply.
Yes,
Sometimes in a moment you can do a like stupid mistake in times instead of add, and then whole thing's wrong. So yeah,
solving equation, we noted that when we are solving equation, do not cancel
right. Yeah,
variables
that's the
on either
key.
side. Bring them together, factor them out. If you cancel,
Yeah,
you're losing one
you
of the.
lose a value.
And
Yeah.
on purpose, that question is given to you because half of the students are going to cancel and find only half the solution. You see that?
Oh,
So you have to bring them together, factor, and then provide the solutions. Okay, so factoring techniques is another very important criteria, right?
Hmm. Yeah, yeah.
So all the best for your preparation. We'll end up here, and let me know
Thank
how
you so
this
much.
strategy works for you. Okay.
Yeah, this seems like great. I can't wait to like continue doing it, because I think that definitely out of all methods there are out there, this has to be the most efficient way to revise, especially for end of year exams, because it's everything coming together, you know. So yeah, thank you so much, sir. I appreciate
Have a
it.
great day. Bye.
You too, sir. Bye.